think now we are done with all the electrical stuff that we were supposed to do on this car. Well, hold on, Elin, hold on. There's more electrical. You're forgetting something. We have to deal with this temperature sender, remember? So, no, we're not done with the electrical. Alright, so hi guys, welcome to the next episode of the Rusty Beauties. We are on the TR4 again, the 1964 TR4. In this episode we should start dealing with the distributor, but I want to finish with the electrical, and I totally forgot that I need to deal with this temperature sender situation. Because if you remember, our temperature gauge was showing maximum temperature even after 1 minute of running the engine. So I got a new temperature sender and I got also new voltage stabilizer because that might be an issue as well. So let's get crack-a-lacking on that. Alright, so what we have here is the new temperature sender and the old one. So we're going to compare these. And we have a new voltage stabilizer as well. But before we start testing them, I want to explain what we're going to be testing. So how our system works, the gauge needs to have a constant voltage input. The engineers chose to make it at 10 volts, and I'll explain why. So anyways, we have 10 volts input of the gauge, so that's our gauge. So that's positive. And on the other side we have the temperature sending unit, which is basically a variable resistor. So it is some kind of resistor which is grounded on the other side. It's a resistor that's controlled by temperature. The higher the temperature, the lower the resistance, I believe, because when we shorten it, when we connect this end of the gauge directly to ground, it goes to the maximum. So the higher the temperature, the lower the resistance, and the more the gauge moves to the hot side. The colder the temperature, the higher the resistance, and the more the gauge moves to the colder side. So that's basically how the temperature works. And for the fuel gauge, it is the exact same thing. We have the fuel gauge, and we have, again, variable resistor, which is actually something like this. So we have a resistor here, and we have a ground. And this pointer is controlled by the float. So the higher the float, the higher this pointer goes, and the higher the resistance here. And when the float goes down, let's say it goes this low, now the pointer is here, and it only takes half of the resistance here. So again, this is another type of variable resistor, but the whole circuit works the same way. So it again requires 10 volt positive. Why does it need to be constant voltage? Because the same resistance at different voltage is going to show us different reading here. And as you know, our generator or alternator varies. Sometimes it charges with 13 volts, sometimes it charges with 14 volts, sometimes it even charges with 12 volts. So we need a constant voltage. So the engineers decided to make a voltage stabilizer that is going to give us 10 volts output, because that's a little bit lower than the maximum that our generator or alternator produces. So even if our generator is a little bit old and it doesn't go to 13 volts or whatever, it always goes above 10. If it doesn't go to 10, then our car is not even going to start and it's not going to charge. So anyways, these two gauges, they need 10 volts, right? So how do we deliver 10 volts to these gauges? With the voltage stabilizer. So the voltage stabilizer has 3 legs. One is 10 volts output, one is 12 volts input, 12, or we call it 12, but it might be 13 or 14, or it might be 12. So it doesn't matter how much voltage goes in, always we need to have 10 volts out. And here we also have another leg, which is ground actually. So the old style voltage stabilizers, the original ones to the cars, were controlled by a bimetallic arm inside the voltage stabilizer. This bimetallic arm had a little coil around it that is actually a heater, so it's connected to 12, 13, 14 volts, whatever goes on one side, and the other side of this coil is connected to the ground. So when this bimetallic arm is closed, this heater starts heating, and it heats the bimetallic arm until it bends and it opens the circuit. And now the heater is off. So now the bimetallic arm starts cooling down and it starts getting closer and closer to this contact again, and then it closes. As soon as it closes, the heater is on again and it starts bending it again, and as it bends up, it opens the circuit. When the arm is open, we have 0 voltage output. When it is closed, we have 12, 13, 14, whatever input we have. So in fact, we don't have constant 10 volts output. We actually have certain amount of time at 12, 13 or 14 volts and certain amount of time of 0 volts because the circuit is open. So this little heater is designed in such a way that the time between open position of this bimetallic arm and the closed position always averages at 10 volts output. So for this reason, if you actually take a voltmeter and you touch here the output and a ground somewhere, it is not going to show you 10 volts. Your voltmeter is actually going to go crazy because it's going to be always 14 or 0, 14 or 0. So the only reason to measure it accurately is with an analog voltmeter. Because here the pointer at 14 is going to try to go to 14, but if in the meantime the circuit breaks, it's going to try to go to 0, but as it goes down, the circuit is going to close again and it's going to start going up. So basically the pointer is going to average at 10, or it should average at 10. So that's one thing that we want to check. We want to go on the existing voltage stabilizer and go with the analog meter and see if we have 10 volts output. And the other thing that we want to check is the resistance. We want to see what the resistance is in this ambient temperature, and then we might just put them in hot water and test them again. So that's about, come on. Let me do this. I'm gonna do this and this, so it is more stable. I'm gonna use this and then this, like that. Let's see. Okay, so that's 893 ohms at this ambient temperature. So let's check this one. 450. So this has half the resistance of this one. 450. Let's do that again. Come on. Yeah, 826, 25. So the temperature right now here is at 13 degrees in the garage, 13 degrees Celsius. So we have the new one and the old one. The new one has 827 ohms, and the old one was what? 452. So I'm gonna go bring a cup of hot water and we're gonna do the same thing. All right, I don't know what temperature this water is. I think it's about 125 Fahrenheit because that's what my tankless water heater is set to. Where's my, okay. So we drop down to 100 and the old one shows 220. Keeps going down though. Come on, my water is gonna cool down. Okay, we're going lower than 200 now. You know, I'm just gonna let it, I'm gonna sink it there. And I'm gonna test this one too, so we can compare them quickly. Come on, just stay there. So we're gonna call this 50 degrees Celsius because that's 125 Fahrenheit is about 50 something. Okay, it stopped. So you see where it stopped? At 237. Let's check the other one again now. It should show us right away if we don't take it out of the water. Come on. 174. So there you go. Bob is your uncle. So I'm sure that this is the problem, but we're gonna go check the voltage stabilizer too, now that we're set up for it. Actually, before we go and check the stabilizer, I just want to mention something that I forgot. Some people mentioned that maybe the conversion from positive to negative ground affected our voltage stabilizer. Well, the mechanical one with the bimetallic arm inside shouldn't be affected by the polarity, because whether you connect it this way or this way, this bimetallic arm is always working the same way, and the heater and everything. So the old one is not affected by the polarity. The new ones though, the aftermarket ones, they call them solid state ones, the voltage stabilizing is happening electronically inside. So all the little transistors and capacitors and stuff inside, of course, they are affected by the polarity. So that's why the aftermarket ones, they sell you one for positive ground and another one for the negative ground. The old ones, they were the same for positive or negative ground. So I'm not sure whether we have a solid state one or we have a bimetallic one in the car. So that's why let's go and check whether we have 10 volts output or not. All right, so I used my jumper wires and I connected them over there to the voltage stabilizer. So that's my voltage stabilizer there in the corner. And as you can see, I connected the red one to 12 volts and the green one is connected to the 10 volt supposedly output. Also, I connected the black one to ground over there to the transmission. So now I can do my measurements here. Before I go too far though with this thing, I want to make sure that it's showing correct reading, because to be honest, I don't remember when was the last time I used it. Can you imagine? Wasn't that long ago when people were using analog meters. Anyway. Okay. So, with this is my power supply. It's 14 almost volts now. Almost 14. And this thing shows, does it even show anything? Yeah. Okay. So we are at the 250 range, but I have no idea where to look. If we go to 10 range, okay, it goes over. Is it the black ones here? I don't know. Let me set it to 10. Let me lower it. So that's, oh, that's 0, okay. Let's see. That's 7 volts. So yeah, so we're looking at these. So we're looking at this, the 0, 2, 4, 6, 8, 10. So that's about 7 volts, 7.2. Yeah, somewhat. So 10 volts. So we are 10.15 now, 10.1. Yeah, exactly 10 here. Perfect. So that's what it should show us there. So let's go check. So let's connect black to black and green to red, right? Wow. Okay, the ignition is off, that's why. The ignition is on. Is it on focus? No, come on. Okay. So this is what's happening. Never reaches more than 8 volts. That's interesting. Okay, so obviously this voltage stabilizer is not the best either. So you know what? Let's check the new one. And this is our new one, which is solid state. So I'm assuming we can measure it with our digital voltmeter. But I want to measure it also with the screen. So what unit do we have? We have 131555. Negative ground. Okay. So this is the unit that we have. The unit must be bolted to chassis ground in order to function. Hooking the wires to the unit incorrectly will damage it. Actual parts may vary from image. So anyways, B is for battery, I is for the gauges. So we're going to connect the ground and we connect this to B on this side, and let's measure now. So this is going to go to ground 2, and here we have 13 volts, and on this side we have 9.72. Solid, you see, because this is doing whatever it's doing electronically. But I'm just curious, I want to see what our other meter shows, the analog meter. Same thing. Come on. I need one more hand. And there you go. 9.7 whatever. So our analog meter is correct too. And this means that our voltage stabilizer wasn't really good. It was going only up to 8 volts. How do you don't even need to turn this off. There's no battery or anything. So it's a good thing we have a new voltage stabilizer and a new sending unit. We're going to change them both, and I'm sure that our temperature reading is going to be perfect. So yeah, this is the only reason why I'm keeping this analog one. All right, so the new one is installed. So let's go change the sender now. Okay, so the new sending unit is installed. I put some thread sealer and it made a mess all over the place. It's wow. Anyway, so now let's see what we can do about this vacuum unit. Oh, we're gonna change also the rotor, have a new one. So this is the new vacuum unit. It is 551045 from Most Motors. It is specifically for this distributor. The distributor has a number here on the side. So this vacuum unit is for this particular distributor. Okay, that's better. Here there's something that I thought it was handmade, but it's actually somebody commented and said that this is the genuine part for here. So we have to be careful not to lose it because this one comes without it. Took it out. Haha. So now we just have to turn this nut until it comes completely loose. So here, this nut is used for adjustment actually. You can see also the whole plate is moving as I'm turning the nut. It is marked here A and R. A for advance, R for retard. You can do fine adjustments. So unfortunately we have to remove the plate here because we need to disconnect the spring from underneath. Okay, now we can disconnect this spring from here. There you go. Okay, so we have a spring here and the nut. So here's our new unit. And we have to reuse our spring here on the other end. The new one comes without the spring. So the nut has a slot for a screwdriver and we need to push it inside there first. Okay. So we're gonna put it somewhere in the middle. So when we adjust our timing, roughly, then we're gonna be able with this nut to do the fine adjustment in both directions. So that's why we're gonna leave it somewhere in the middle. Now we can put back the plate. Now when we installed the electronic ignition last time, we determined that we don't need to touch the hose, because here between the magnetic ring and the igniter we need to have a gap of 30 thou, but it has plus or minus 15 thou, so it is pretty big tolerance. But anyways, we determined that we don't need to round our hose, because the instructions said that if that gap is out of tolerance, we need to make the hose on the igniter plate oval, and then we're going to be able to adjust it. But we determined that we don't need to. They were pretty good, so we're just going to tighten the plate now. Let me put this little thing there. Okay, actually went back in. Okay, so now let's test it. Let's see how it moves. So for this, we're gonna use my vacuum pump. So it's not correct, it doesn't show 0, but when I plug the hole, it builds up vacuum and comes back. So it loses it somewhere, but at least we can see if it is gonna move. Yes, you see our plate is moving. So I wish I could see how much vacuum we need to move it all the way. There's 2 screws here. Can they be calibrating screws? I don't know. But you know what? Let's see what number. I'm going to tell you how. Let's see at what number the plate is moved all the way, and then we're going to measure with the other vacuum gauge. We should be able to measure what this number actually shows. So it starts moving, and right here I'm going to mark. You see this? Okay. So in this position it's all the way, and now this is all the way down. So it moves between these 2 positions. So let's see when it is going to reach. Here at this vacuum. So that's, what is this, 15, 18, or even earlier than 18. Yeah, so around 15 actually, according to this gauge. That doesn't mean that it is real 15. So at about 8, according to this gauge, which we're going to confirm what it is retarded all the way, and then it starts getting advanced. I'm going to go really slow, and at around 15, at around 15 it is advanced all the way. So between 8 and 15. So let me take the other gauge and check how much that is, the real values for these positions of the arrow here. So obviously our 8 here is 0, but let's see what does 15 mean. So 15 on this gauge equals 5 on this one. So our distributor should be fully advanced at 5 inches of mercury. That's it. And I wanted to know that number because I want to disconnect this vacuum line from here and measure when our engine actually produces 5 inches of mercury. So I know more or less at what RPM our distributor is going to be fully advanced. All right, we have a hard line here which snapped actually, but even if it didn't, the new vacuum unit is different than the old one, so we wouldn't be able to use it anyways. So I made this temporarily just for our test, and then we're going to figure out something more solid for the vacuum. but I wanted to make sure that it works well. And I took my vacuum pump again and I connected it to the carburetor side of this line, the hard line. And now when I build 15, we don't even lose it anymore and our distributor stays advanced. This tells me that this here holds well for now, but I just wanted to test it like this for now so we can start the engine actually. All right, so on this side, this is the line, and what I'm gonna do is I'm actually gonna put a T on the vacuum so I can check it constantly. And this I'm gonna plug down there if I can. Okay. Is it gonna stay here? I hope it's gonna stay. All right, now we can assemble the distributor and start the car. So we shouldn't forget our rotor. Everything inside is okay. Oh, we should put the new rotor. So you see this is the old rotor. It's playing back and forth. This one is not. So I'm hoping that this is better. We're gonna keep the old one in the glove box just in case. We have our ignition disconnected, so we should connect it now. Because of all the electrical stuff that I was doing, I didn't want to burn the electronic ignition. So now we can finally connect it. Number 1, 3, 4, and 2. Battery connected. Let's open the door and see if she's gonna start. Yes. All right, so she's warmed up already. So we're gonna keep an eye on the temperature. And now she actually is running pretty well with the current setup as it was. So I'm looking at the gauge here, the vacuum gauge, and it's reaching 5 inches of mercury, pretty low. So somewhere here at this RPM, my distributor is fully advanced, I guess, but it starts earlier, of course. So anyways, I just wanted to make sure that my vacuum port on the carburetor is working properly, because, you know, if it was reaching 5 inches of mercury at 5,000 RPM, this means that my distributor will never gonna be advanced. Now I know that at this RPM, it is already fully advanced. All right, so let's see how we're gonna do the timing here. Will she start again? Yeah. Anyways, so I don't have a strobe light, but we also don't have the grease on the pulley in the front. Anyways, so we can't really do much with strobe light, but we can do the timing according to the procedure in the manual. So the manual tells you to set the pulley at top dead center, which we have a mark on the pulley. Once you set it at top dead center, the same way as I was doing my timing before, we can turn the distributor until we get spark on the first cylinder. And that means that now our ignition is set to 0 degrees or at top dead center. But according to the manual again, they want it to be at 4 degrees before top dead center. Well, that 4 degrees we can adjust with this knob here. Towards me is advanced, in that direction is retarded. So once your timing is set to 0 degrees or at top dead center, then you can turn this road nut here until here there must be a scale on this side of the vacuum unit, but on the new one there's nothing. However, we can see it here. I'm gonna go clean it on the wire wheel a little bit. So now you should be able to see it. So here we have 1, 2, 3 increments. The third one is the big one, and there is even one more. So we can measure from here and transfer that distance on the new vacuum unit. And each of these increments is 4 degrees. So once we set it up to the top dead center, the ignition, then we can turn the knurled nut until we see another line, and that's gonna be it. So as a beginning, I'm just gonna draw a line here. I'm gonna do it with my Sharpie, like this. I don't know if you see my line here. Now we're gonna set up the ignition to top dead center. All right, so now let's remove the cap. Okay, so we are a little bit past cylinder 1, so we're gonna turn backwards. Let's see, without removing the spark plugs, it's gonna be tricky, but we should be able to. Okay. Okay, so my pointer here in the front points to top dead center, and my rotor points in this direction, which means that cylinder number 1, this is where cylinder number 1 should fire. Sorry, so now we should turn the distributor anti-clockwise. I can disconnect this for now. Oops. Okay, we're gonna get this later. And we're gonna put back the cap, because we need it, or maybe even more. We're gonna put an old spark plug on the cylinder number 1. And let me zoom you in. Okay, I even turned the lights in the garage off so I can see better. I know for you it's not very different, but that's because the camera adjusts. That's amazing. The camera adjusts for dark environment, and it shows you pretty bright. But for me it's pretty dark, so I can see the spark. I have an attachment that you can connect in series with the spark plug, and it gives you bright light, but I can't find it. So that's how we should do it. I'm going to turn the ignition on now, and we have to do it pretty quick because we don't want to keep the ignition on for a long time with the electronic ignition here, because we might burn the igniter. So I'm going to explain first what we're doing. I'm going to start turning the distributor clockwise, which essentially means that the rotor inside, in relevance to this distributor, is moving counterclockwise, which is the natural direction of rotation. So as soon as it fires there, that's our timing, and that's going to be our top dead center timing. And like I said, then we're going to move it with the knurled nut from there to -4 degrees. So I'm turning the ignition on now, and let's go. Turn it slowly. Oh, come on. There. That's it. However, even in the manual, it tells you that this is just initial setup, and then it should be adjusted for best road performance. So they're basically telling you, play with it until you like it. And that's what I'm doing in general, but because some people were like really on my case last time. So anyways, let's see how it is gonna run now in this situation. Of course, we're gonna turn the knurled nut now. I'm just gonna, okay, advance, not retard. So I'm just gonna eyeball it because can't really measure it. But yeah, it's like something like 1/8 of an inch. Okay, that's it. Let's see how it is gonna run now. It's a little bit shaky, but if that's what the manual says. Alright, so now in this situation with the timing, finally we can say that our timing is supposedly perfect according to the manual. I'm gonna check the carbs again. And I'm not gonna explain the whole procedure again because we've done it before with you in previous videos. So I'm just gonna check the airflow again to make sure that it is good for both sides. Yeah, it is pretty much even. So now let me see what's going on here. Rich. Do that again. Pretty good. A little bit less. Perfect. What about this guy? Rich. That's good. There you go. So anyway, that's where we're gonna leave it, and of course after a road test we might play a little bit more with the timing, but we can't road test it for now because you see there's snow, my backyard is muddy, I don't want to drive the car through it. So yeah, so what's left here is I'm gonna figure out a better way for the vacuum. I'm gonna get a new vacuum line for here because this is made up right now, and that's it. Oh, by the way, I forgot to show you this. Look at that temperature gauge, eh? We solved it. So gauges are now working. Unfortunately, that one that one is working too, believe me. We ran it out of gas with all the adjustments and everything, but even there, when it's charging, it goes to positive, not to negative. Let me turn on the lights. Yeah, you see? Don't die on me now. Yeah, I don't like this timing, but whatever. Okay. Anyways, I don't like this timing, like I said, but we're gonna test it on the road one day, and then we're gonna do fine tuning. You see, it's running well, but the idling, I don't like how it idles. So I have the feeling it needs to be a little bit, that's where my heart shows. So at the end of the day, okay, my smoke detector started beeping, even though the door is open. Anyway, let's turn it off. And yeah, we will see if there's gonna be anything else. This is soft. Okay, I'll be back when it stops beeping. All right, so yesterday I went inside because it was too smoky in the garage, and I went inside to wait until it vents a little bit, and I never came back. I mean, I came back to close the door. So anyways, that gives us opportunity now, before we end this video, to do two more things. One is I want to do a compression test, because I've done one compression test after the rebuild. Okay, that's soddy, but I guess that's because we were idling a lot. Anyways, I've done one compression test after the rebuild, but our starter wasn't great, remember? So now that we have a good starter, I'm gonna do one more compression test. So the results were pretty good, but now I wanna see what the actual numbers are, because like I said, because the starter wasn't best. So all our spark plugs are soddy, but I think that's because we idled it for a long time. So anyway, so that's the one thing I wanna do, compression test. I have here the results from before we rebuild it. And the second thing is, of course, I want to do a cold start. Now with the new setup, with the new ignition timing, with the new vacuum unit and the new carburetor setup, I want to see how it is going to start cold. I'm not going to warm it up because I don't want to keep the door open. It's chilly today, so I don't want to open the door. But we're just going to do a quick cold start, and that's going to be it for this video. So let me disconnect the coil and the ignition, the electronic ignition. Is there a point of blocking the fuel line? No, because there's fuel in the float bowls already anyways, so no point of that. But I'm still gonna put a charger on the battery because this battery is not the best. All right, let's see that. Okay, I don't know if you see, I might move you a little bit. Well, I know, lights, whatever, I'll tell you. So that's cylinder number 1, and before, for cylinder number 1, we had 118 psi, 118. So now I'm gonna go full throttle, and we're gonna crank it. That's 8 cranks. And we are at 180. That's a little bit better than 118. So from 118 to 180, that's a little bit of improvement. So 180 psi. Let's go cylinder 2. Full throttle. $180. So this one used to be 131. Number 3. Number 3 used to be 115, so this was the lowest one. Well, 181, 182, 181. Pretty consistent. And the last one used to be 145. So you see, that was the main reason why we decided to rebuild this engine, because it was very inconsistent. It was, the lowest one was 115, the highest one was 145. So that was a pretty big range, right? So now let's see this one from 145 where it went. $180. Super consistent. Wow. So we have a great result. Having new pistons, new rings, new cylinders, and new valves makes a difference, right? So ignition coil and electronic ignition connected. So let's cold start it. Choke. There you go. Okay, I'm not gonna keep her running because I don't want to contaminate the garage. But yeah, she starts pretty well. Even at a cold engine, she starts pretty well. So that's it. Let's wrap it up here for this episode, and in the next one we're gonna put together the front suspension, and hopefully the weather is gonna allow to go out and test drive it, because I don't want to put the transmission cover on before I test drive it. I want to make sure that my wiring is working properly, the overdrive is working properly. I know I can do that in on jack stands here, but anyway, the weather is not too bad. I mean, it's 4 or 5 degrees Celsius outside. The problem is my backyard is pretty muddy and I don't want to drive the car through mud, but if everything else is ready and we have to, we're gonna drive it through the mud slowly and then I'm gonna wash the tires. Anyways, I'm happy with the results, happy with how everything turned out, and now I can sleep normally. Anyways, that's gonna be it for today, guys. Thanks for watching, thanks for commenting, subscribing, sharing, supporting the channel and all that good stuff, and I'll see you in the next one. Bye.